Hi, I'm just doing a short video on the rock cycle. I know we can't always be together, so this will be for those times when we can't be. So here is an example of a rock. I know we might have already talked about minerals. So a mineral is like one chemical composition material, like a crystal. I have an example here behind my computer. I have a slice of quartz. So this is all made of the same mineral. One mineral, quartz, looks pretty similar throughout. But a rock is usually made of more than one mineral. And we have an example here of a rock that has some black areas, some pink areas with other black crystals. So there's at least 2 or 3 minerals in here. And I'm going to give you kind of an introduction to the 3 major kinds of rocks and what the rock cycle is. And the 3 major kinds are igneous, sedimentary, and metamorphic. I like to talk about them in that order, but some people talk about them in other orders, and it doesn't matter. There is no like original rock. But to me, the igneous rocks are the original rocks. These are the first ones that formed on the earth. So I like to start with those. So here is a rock cycle. Let me see if I can get rid of my weird drawing there. Here's an example of the rock cycle. And this looks kind of complicated, but it's really not that bad. Let me show you with some colors here. We have 3 major kinds of rocks. We've got igneous rocks, sedimentary rocks, and metamorphic rocks. And then we have these other things in between. We've got magma, we've got sediment. So I'm going to use another color and kind of add to this. Let's see. All right, so I'm going to start with igneous rocks over here. And igneous rocks are the ones that are formed from a melt. So a melt is any kind of melted rock material. So the crystals of minerals are starting to form in a liquid. And then as the liquid cools over time, more and more crystals will form. So originally a magma will probably feel kind of like a gritty soap, like an exfoliating soap that you might use, because it'll have little crystals that have already started to cool of different minerals. And then as it cools further, it will cool the entire thing, and the entire liquid rock will eventually probably become a solid rock as it cools. I don't think we'd want to rub around some magma though, because that would probably be 1,000 degrees. So anyways, I'm going to add something here. So magma is inside of the earth. Lava is outside of the earth. You might think, well, this is dumb. Why do we care? This seems very similar. But this is because they have different properties. They create different types of rocks. So being able to name the melt in a little more specific way is really useful. So lava is below the earth. Magma is, oh, nope, I got that backwards. Hold on. I'm not very good at annotating. All right, let's try that again. Lava is above the earth and magma is below the earth. Okay, perfect. So if we've got these materials and they're cooling, why might they cool? What temperature would you say is the surface of the earth? The average earth temperature is like 50 degrees Fahrenheit, maybe. If you average the entire earth, I'm not really sure. Between 50 and 60, I would think. And I said that magma and lava is about 1,000 to 500 degrees. So why would it cool? Maybe the magma is slowly working its way up through the rocks underground and getting shallower and shallower until they get closer to the surface of the earth. Do you think that a rock would form at like when it hits 50 degrees, or do you think it would happen earlier? I don't see any melted rocks just laying around. So I would say that a magma would really start to cool around 500 degrees and continue cooling. And so it would probably still be hundreds of degrees when it cools. It takes a very high temperature to melt an igneous rock. So the magma could be lifting up because it's less dense, it's working its way and cracking through the rock and the crust, and then it could eventually cool off. So that's one way you can make an igneous rock. You can see it even says cooling. And then lava, where is lava? Where do you find lava? I like to find lava at volcanoes. That would be awesome. I've never seen a real volcano erupt, but it would be pretty awesome. So lava is mostly at volcanoes or like places where the crust has cracked open and magma has come out to the surface as lava. And so that's going to cool pretty fast because it's going to be instantly going from 1,000 degrees to whatever the surface temperature of the air is. So those are different ways to form igneous rocks. Can anything become magma? Any kind of rock can become magma or lava if it gets hot enough. So you can see that metamorphic rock here, if you give it extreme heat, it's going to melt into magma. I'm going to add a line here. Sedimentary rocks can melt and create magma and lava. Even sediment could be melted to create magma and lava. Can igneous rocks melt and become magma and lava and then make a new kind of igneous rock? Most definitely. So my favorite annotation to put onto the rock cycle is this one. An igneous rock can melt and cool and become an igneous rock. So we can say it could melt. Melt. I'm not very good at writing with this pencil. Melt. It could melt, become magma and lava, and then cool to become an igneous rock. So that's very common, because where do you find a lot of igneous rocks? Around volcanoes. Where do you have a lot of rock getting melted? Around volcanoes. This is very common. Or mid-ocean ridges, all kinds of places where that material is coming out. That's a common place for more magma and lava to be forming. So let's get to my favorite kind of rocks, sedimentary. I'm going to use blue because a lot of sedimentary rocks are associated with water. So if you have igneous rocks and they are weathered and eroded, this could create sediment. Weathering is when rocks break down into smaller pieces, and erosion is when those pieces are carried to a new location, usually by water. Maybe the rain is like trickling down and slowly these particles are going downhill. Maybe a river is carrying sediment, maybe the ocean currents. So a lot of this is associated with water. A big on-land example of erosion could be sand dunes in a desert. So that's, the air, the wind pushing some sediment. So I have a couple examples of sediment here. My favorite types of sediment are made from shells of different creatures. So this particular sample has a bunch of different weird shells, calcareous algae, corals, little snails and stuff. So this is from the Florida Keys. That's a place where a lot of creatures are living in the ocean, creating sediment. Ooh, my favorite little fossil is in here. I even have a limpet. That's a little fossil of a little gastropod shell. So sediment could be made of little pieces of stuff, broken up. Minerals in shells, that's still a mineral, still a rock. The most common one people think of is just straight up sand, though. Here's some sand from Fort Myers Beach. So sand, little pieces of shells, any kind of broken up rock and mineral can be sediment. And then if that sediment is buried underground, or it's buried just under more sediment, like in the bottom of the ocean, there can be layer and layer and layer forming up on top of each other. This material can get compacted, and then the little grains can get cemented together. In this case, cement is like, think of rubber cement, so a type of glue. And this cement is made of little tiny crystals of minerals that form in between the grains. I am not going to try to draw this because I'm not very good at drawing on Zoom. But anyway, so you can get little pieces of sand, they get compacted, and then they could get stuck together to form a rock like this. This is an example of sandstone. You can see some different layers in here. So sandstone is when you have sand cemented together. Here's another sandstone example. What about if you have shells and particles from the bottom of the ocean cemented together? Here's a great example from Florida Gulf Coast University campus. I just found this outside the Student Union, and it has these really nice big shells in it. So this is called a limestone, and this is made from shells and different particles from creatures that live in the ocean, for the most part. You can also have bigger things like pebbles in a river, and they can make a rock such as conglomerate. So, can any rock be weathered and eroded to make sediment? Definitely. So, sedimentary rocks can be weathered and eroded and then compacted to make a new sedimentary rock. A magma? No, that can't form sediment. But an igneous rock can, right? Weathering and erosion. A metamorphic rock can, weathering and erosion. So there you go. So then if you have a sedimentary rock, let me switch to a new color. I'll try yellow for metamorphic rocks. If you have any kind of rock and it gets buried and buried, we talked about sedimentary rocks getting buried and compacted under layers and layers of rock or sediment. But if you keep going with that and it gets buried miles deep in the crust, this can create a lot of pressure. And remember, one of the kind of driving forces of which mineral you end up getting is reliant on the pressure, the heat, and the chemistry of the environment. So if you have a lot more pressure, this is going to change the types of minerals you have. So therefore, it's going to change the rock. So if you bury a sedimentary rock under a lot of heat and pressure, you could form a metamorphic rock. You could bury an igneous rock under heat and pressure and make a metamorphic rock. If you have a rock that's miles deep and then it gets pushed further down, that could actually change the metamorphic rock from one type to another. So it's very common for a metamorphic rock to become a new metamorphic rock. So I'm going to write heat and pressure, H plus P. So most rock cycles don't think about the fact that igneous rocks usually turn into other igneous rocks. Sedimentary rocks often turn into other sedimentary rocks. Metamorphic rocks can turn into other metamorphic rocks. So it all kind of works out. And then if that metamorphic rock is buried so deep that it melts completely because it gets too hot, what's going to happen? It's going to become magma. And the cycle can start again. So the cycle kind of goes around. And why is this important? One reason is we're not getting a ton of material from space. So how would we make new rocks if the material on Earth wasn't getting recycled? So check out some other information that I will share with you about other rocks and details on the different types. And I will see you soon, hopefully. Bye.